Thanks for joining. This talk has been about 6 months in the making, actually. So let me just dive right in. My name is Jeremy Seitz. I'm a hacker and musician from Ricardo.ch. That's actually me 20 years ago. So I've been doing synthesizers for a while, but then I took a break, and somehow this whole rebuilding of Ricardo renewed my interest in modular systems. So first of all, this is a patch cable. It's just a regular 3.5 millimeter mono patch cable. And this over here is an oscillator. An oscillator produces waves, sound waves. So here we're going to hear, hopefully, a sine wave. So that is a sine wave. This is a sawtooth wave. It's a bit harsher. And this is a square wave. Now, that's not interesting. What's actually interesting is there are some knobs here, and the knobs allow me to control the frequency of that wave. Which I could do that for hours. But what's more interesting about a modular synthesizer is about the fact that you can do so much more than just turn knobs. You can actually, this act of moving this knob can be automated. So I can take another patch cable and plug it into this control here, this jack right below it, and I can find another knob somewhere else. And now I can use this completely different knob over here to do what I was doing there. Okay. So that's relevant. So we looked at 4 different kinds of waves, actually 3, but there's 4 different basic waves that are produced by an oscillator. And the frequency can be very fast or very slow. But let me first talk about the synth, this monster beast you see sitting here. Each one of the rectangles is a module, and a module is basically a sandwich of circuit boards. Most of the modules in here are analog. This particular one I built from a kit. The kits are really fun to work with. Some of them are very professionally produced with instructions. Some have no information whatsoever. And a lot of the modules I actually bought on Ricardo. So Ricardo has a thriving community of modular synth people buying and selling stuff. And as I've discovered, it's what you do all the time. So I load this page probably 3 or 4 times a day to just check and see what's new. I started out with a very small synth. I just wanted to experiment. So I had 2 modules. One was a synth voice and one was a pattern generator. And very quickly I found that I needed other things to do more. So I ordered more modules and built more modules from kits. And then pretty soon I had filled up my case. And I was able to do a lot of cool stuff with that, but I wanted even more. So I added a second case. And the second case started to fill up, and then my goal changed a little bit, and I decided I wanted to be able to do pretty much everything with this synthesizer. I wanted to make any kind of sound possible with it. And then I added another row, and pretty soon I had reached the maximum capacity of commercially available cases. So with doing some research on how to get around this limitation, I actually discovered I needed to build my own case. So my design was inspired by the Buchla system, music box system from the very early 1960s. I like this curved spaceship thing. So I learned how to actually cut wood in proper circles after wasting many plywood pieces. Then I discovered how to actually line the racks up really well to make the shape, because you don't want to do that last, it will be wrong. And then I finished out the rest of the synthesizer and needed bracing and everything like that. But I didn't want to have any screws visible on the outside, so I designed and 3D printed the connectors for the wood. And actually this is a really cool form of construction. It's quite strong. And the rails had to be custom ordered from a company in the UK who cut them exactly to the size that I wanted to, with all the holes pre-drilled. And then the power supply was ordered by a very liberal company in California who has the motto that they kill fascists. And they custom made an order for me and sent me the power supply boards, which had to be wired up in sequence. So overall, this synthesizer is actually capable of 10 amps of power at 12 volts and can hold 150 modules. Today, I am using 5 amps of power. I measured it, and I'm using 71 modules. So I'm only at 52% capacity, which means that I have failed, my OKR is not achieved, and I will need to do better next quarter. The plan for my synthesizer is actually this, which I planned it out on Modular Grid, which is a website specifically dedicated for people to plan out their modular synthesizer. And they have a database of over 6,000 modules. There's 2,500 of them in production today. And you can actually drag and drop. It's a really cool web app. It'll calculate power. And like any good product person would tell me, I need to have a product vision. So this is my product vision. That's actually me, and what I'm imagining I'm trying to go for here. And by the way, if you're interested in learning this stuff and you maybe want to get back into music or whatever, I would highly recommend that you not consider going into keyboards and synthesizers, because as I discovered in my personal life, they lead to more keyboards and synthesizers. So you might be wondering at this point, how is Ricardo doing? So we just finished building our platform. We have been building new services, microservices. We've learned a lot of new technology. Now we're trying to figure out how they all fit together and how we actually make the music or the product work better, I would say. But you might be wondering, how many microservices does Ricardo actually have? Well, we have 90 in production approximately at the moment. We have over 450 repositories on GitHub that we've created, but that just tells you how many of those are actually making it into production as live microservices. But aside from that, let's talk about filters. So a filter is something that changes the sound of the audio coming out of a sound source. So let me try. So this is a sawtooth wave, and I'm going to take this out and plug it into a filter here. This is called a Jove filter. It's actually an open source design. Let's see here if this works. Okay, there we go. Something very wrong with the audio quality here. Let me check that. Okay, let me try a different mixer. Okay. That's annoying. Okay, let me just do some troubleshooting here real quick to see. I might do a power cycle. That could help. All right, hold on. Hopefully nothing explodes. I've been told they turned off the fire alarm for this talk. And I'm not joking. Sometimes things get messed up and you have to reboot to get the levels right. Let's see if this works a little bit better now. It's on 5, 6. So it's not quite sounding as good as it should, but a filter is changing the sound. It's basically like an EQ, so you have treble and bass, and it adjusts the sound, and it should sound really cool. But this one is having a bit of trouble. Yeah, there's something wrong with the audio path, I'm thinking. You know what I'm going to do? As I'm an engineer, I'll try unplugging some things and see if maybe there's a cross-connect problem somewhere. 5, 6. No difference. Okay, I'll move on. So the filter basically takes the cutoff, and you choose a particular frequency with the knob, and it cuts off all the sound above that frequency, a low-pass filter will. And what happens is there's a magic sound that kind of happens. If you've listened to synthesizer music, there's a very specific, beautiful noise that happens with the filter. And it exploits the harmonic sequences that happen. So if you play guitar, you know that there's sweet spots on the guitar string, and the same happens with analog waves. If you're able to find those sweet spots, you can do all kinds of cool things with them. This particular filter is a reproduction of a Jupiter 6 filter from a keyboard that came out in 1983. And one of the things you'll notice about this keyboard is it's not modular, it's one product. It's a wonderful keyboard and it sounds great, but as time evolved, the keyboards became more and more complicated and they became more and more digital. And if you were to buy a keyboard in 2016, aside from the vintage thing, reproductions that they're making, a lot of keyboards ended up going in this direction, where you basically end up with a computer screen and controls for it, which for me is not very satisfying. But if we go back in time before the Jupiter 6 keyboard to 1977, what you'll see is that the products, the standalone keyboards, actually included all kinds of jacks and patch cables, and they were very modular. And why did they do that? Because when they made these products, they knew that the people using them would want to use them in different ways. So rather than them deciding everything for you ahead of time, how all the signals were, they gave you options. This particular keyboard is mine, and that's why there's a broken key on it, because I moved it from New York. So if we go back before even 1977 to the 1960s, modular synthesizers were very large and exotic beasts. They were created by people that were doing research into electronic music, by researchers who were working in an academic environment, or by scientists who had this lab equipment. And at the time, this was before really software had come about in the way that we know it today. But they already knew at that time that the best way to build a giant system was to do it in small modules and to put them into a rack, and to do it in a way that you could easily replace parts and move things around rather than trying to build a finished product at first. This is Don Buchla. He is, in my view, the father of the modular synthesizer. A lot of people think of Robert Moog. That's the most famous name, but actually Robert Moog was not a very good circuit designer. His circuits were noisy, and he made a lot of strange decisions in his designs. But Buchla was a genius. He was a very good circuit designer. He actually came from the microelectronics world before even Intel was big, and he got involved in it was called the Tape Exchange in San Francisco, and started creating these devices to create really trippy sounds, and eventually he joined a touring bus that went around the United States handing out tabs of acid. So, well, what does this have to do with microservices, you might be wondering? So what we've realized is that modular means we have a series of purpose-built modules using common standards for installation, formats, parameters, and even event handling. And these are the essentials of an interconnected system, a modular or microservice system. So the building blocks that you need to create a synthesizer are these, basically. And there's many more different types of modules that you can get, but the point is that each module does something specific, and it does that very well. If I look at Ricardo right now with our microservices, we have kind of the same patterns happening, where we have certain microservices that are good at certain things. They don't try to do everything. Some of them maybe try and shouldn't, but we have a lot that are actually very focused on a particular task. So if I talk about the different types of signals that connect a modular system, we have audio, we have control voltage, and then there are what are called gates and triggers. And this basically corresponds to the sound that's moving, the knobs that are turning or automating those knobs or automating those levels, and the gates and triggers are basically events. So the standards that emerged, if we look at a modular synth today, I would divide it into these four things. It has infrastructure, which are the decisions about the rack size and the power. It has the audio, which are the cables, and all cables are compatible, whether it's audio parameters or triggers. It has the standards for how the parameters and the triggers work as well. Everything is compatible. If I look at microservices where we are with Ricardo, we've also got kind of a standard going on here. It's our infrastructure, which is Kubernetes and the monitoring and the things around that. It's the data exchange, which is kind of like the audio. It's the payload. We have parameters as well, which could be URL parameters in a service, or it could be configuration in a file somewhere. And we have events. For us, a big part of our event-driven architecture is actually using Kafka and sending these kind of topics and channels and things like that. But let's talk about triggers for a second. Okay, so, oh, it sounds so bad. What has happened? Okay, so I'm going to try to do some triggering of things here. Maybe it's just this oscillator. Let's try a different one. I've got multiples. Oh, that's much better. We're going to use that. Okay, so first of all, let me just take a clock signal. When you're connecting sequencers and things in a modular synthesizer, there's a clock that happens, and it's sending little pulses. And I'll let you hear what that sounds like, because if I just plug that clock directly into the audio jack, it will sound like this. Can you hear that? Not really. Oh my God, it's so quiet. What has happened? Okay, so that's not doing anything. But let's try something else. I'm going to take I have another device here which is called a pressure points, and this allows me to tap onto the module, and it will actually switch between 4 different configurations. So first I'm going to take a repeating clock signal and try to plug it into the gate of this synthesizer. That's good. But it gets quieter. That's weird. Oh yeah, that's better. Sounds like shite. What has happened? All right, I'm not going to worry about it. Live demonstration, demo effect. Okay, so I've got that going now. Now I want another kind of event to happen. I could actually change the tempo of this by changing the sequence of how the events are being sent. So I've now doubled the tempo. And let's see, what else can I do? I can take another output from here, and I'm going to trigger it into a drum sound. And plug that drum sound into a mixer. Let's use the same one. That's not making any sound. That's awesome. Why? What is happening? Oh, here we go. My fault. Oh yeah, there we go. Okay. Oh, that sounds horrible. It's really, something's terribly wrong. This is awesome. It is really going to start smoking soon. I've got some kind of a power problem probably. I'm going to start unplugging stuff. Maybe it starts working. Oh my God. Okay, let me continue with the talk for the safety of all of you joining us today. Okay. So the point is that triggers make things happen. So it's not enough to have audio and knobs that you're turning and things like that. You actually need to have events happening within the system. So an important consideration in how synthesizers are designed is also in how they're made. So I've worked with Eddie for a long time, and he trusts me as an engineer. He knows that I test things thoroughly, and yeah. Okay, so when these things are designed, or when you're designing microservices, you have to make deliberate choices about the components, but more than that, it's quality, it's testing, it's overall design. In my research and obsession with these machines, I went back and read a lot of old documentation that was published at the time when these things were starting to become reality. Each instrument is assembled from the highest quality components with a good deal of pride and care. Rigid quality control through testing and many hours of burn-in are applied to each module. Different module arrangements may be more practical for a particular performance, so by rearranging the modules, any system can be optimized. It sounds like talking to a software engineer. Here's another one. This was from Don Buchela's synthesizer, the Music Box. 50 years ago, I picked out the words that were used in this description: conservative design, real-time, lightweight, portability, cost is reasonable. Modular construction permits economical system expansion. All equipment is compatible. Rules for interconnecting are simple and consistent. Doesn't this sound like the type of platform or software you'd like to work with? It really underscores the principles. But in those early years, the problem was that each manufacturer had their own idea of what the standards were. This is a list of the most popular modular synth standards that go back quite a ways, and they had different voltages, different rack sizes, different power requirements, different connectors. So you couldn't buy a module for one system and use it in another. They were also very large and expensive, so if you're a musician, you couldn't take it with you on the road and perform with it. So that all changed in 1990 when the guys from Kraftwerk went to this guy named Dieter Doepfer, and they said, we've been using these kind of like product-made synthesizers from companies like Roland and Korg and so forth, but we'd like to go back to the modular synth world, but we don't want to have to mess with all of those horrible different standards and power requirements. And so Doepfer actually is a brilliant, he's a great designer. He said, look, let's use modern standards. So he used IEEE rack standards, standard server rack configurations like people use today. So you could rack your modular synthesizer in your server room. If you're moving everything to the cloud, that could be a useful thing. And he chose common things like ribbon cables that are used in electronics and common audio jack sizes and things like that. And he used a smaller format, and he knew that surface mount electronics instead of large, big transistors and things like that were around, so he was able to shrink it down. And his first system was called the A100 modular system. He made something like 11 modules to go with it. Nobody really cared. And somewhere in the 90s, he decided with this internet stuff, he would just publish his standards because he loved this. And he said, I want to see other people making modules on forums or whatever. So he published all the standards, made it open, and encouraged people to build and design their own modules that could work with this. And lo and behold, over time, it took off. And today, we have an incredible explosion of small companies doing beautiful, creative engineering work with these modules. Just look at the design of this particular company, Mutable Instruments, are one of the best out there. It's run by this guy named Oliver who lives in France. He's a really brilliant software engineer and a designer as well. He publishes everything, all of his source code on GitHub, and he even encourages people to remix and make clones or variations of his modules. Then there's IntelliGel, which is making these fantastic modules. I own a few of these, and this is made by this guy, Dan. I had one of my modules blow out, white smoke, sent it back to them. They were like, no problem. They fixed it, they mailed it back to me, and inside the box was a lollipop and some stickers. Amazing. This is Make Noise, which is in South Carolina. They make some really trippy, cool stuff that Don Buchla would have liked. Touch things, remixed granular synthesis and things like that. It's a small team. They really run like a software team, these guys. And then it gets even more wild. This company in Spain is making these beautiful designs and really crazy modules. And look at this. This is a piece of artwork. That is copper on the panel of this. It is really crafted like a piece of art. And some of these are very hard to find, and if you're lucky, you might get one, but often they sell out. They can't get the components because they're small companies, and the only place you'll probably find it is if you go to Ricardo. So this stuff all gets built and designed in the same way. We're talking about a few people working together with a dream. They have to start somewhere. They build a prototype. They need to try out different components. They need to mock it up and see if it works. And then once they've done that, they need to actually put it in the hands of users, which are synth enthusiasts or other people, and get their feedback about it. And they iterate, and eventually when they're ready, they start to mass produce their modules. So what does this have to do with microservices? This is a typical scene of what you would see if you were to make a song and on a modular synth or spend 2 hours with it screwing around. The thing is, you look at this and it's like, that's madness. But if you're working on one of these things, you know what every single cable does and every single cable connects to. And part of that is because of the way that things are clearly labeled, because of the functions, you know what the functions do. You can follow the cables back as you plug them in. And in a certain way, if you think about it, when we work on microservices, we don't do it by ourselves. We have to work with a team of people. So if you end up with this in a system designed with microservices, you have a problem. So the important thing there is to begin to think about the experience when you're building a microservice. Now at Ricardo, we're currently building an auction engine, a remake of the one that was from 1999, but it's a simple standalone auction as a service. And imagine if you were to make a Eurorack module out of this. Now this is a proposal for a design that could, in theory, actually work. At the top, you set with the knob how long you want to wait until the auction starts. At the bottom, you say how long the length of the auction must run. On the right-hand side, you can set the amount. So that's the amount the auction is running at. And at the bottom, you have a clock and run and stop. Now, if you want to place a bid, you send a trigger to the top button. And if the knob is turned higher, the bid will be accepted, and you'll get an OK signal. If the knob is turned lower, it won't be accepted, and you get nothing. The current level is always being sent out constantly from that. And when the auction's ended, it sends a trigger. Now, I could get this auction module produced, and it could actually make some sound. I mean, it would be kind of weird. But my point is to think, in microservices, when you're thinking about the design of it, why not consider a user interface as well, to think, how would you actually use that? And the more you iterate on thinking about it, the simpler and simpler the design gets. So in the days of the monolith, we're all trying to deal with the monolith. A monolith is essentially a bunch of pre-made choices that are pre-wired and can't really be changed easily. Whereas microservices is really about breaking things into parts. But it's not just about breaking it into parts along, you know, I could carve this keyboard into parts. Or I can say the obvious thing like, you know, part of the module is the keyboard and part is this thing on the left. But you actually need to consider how it could be rearranged and breaking it down into its simplest components. But at the end of the day, there's not much point to building a complex modular synth unless you make music. And as Mr. Grush said this morning, microservices and a great platform are useless without a great product. So I would recommend that you all watch this documentary. If you like this talk and you're into synthesizers or curious, it's called I Dream of Wires. It came out a few years ago. I think it's on Netflix. And if you're interested to listen to some of the noise I've made on this synth, I'm publishing a couple of times a week on SoundCloud, and I have a whopping 20 followers right now. So, yeah. And so now what else can we make? We're going to see if it'll make anything. Oh, what the heck is going on with this thing? All right, I'm going to troubleshoot it in real time. Let me take 7 and 8 out. What could have gone wrong with this mixer? That is the synth. That's here. Really?
Yeah, it's like, look at it.
Oh. I blame the Wi-Fi.
Yeah.
Okay. Okay, so what I'm going to attempt to do now is to make some melodies. I'm going to take a low-frequency oscillator and plug it into the volt per octave. That sounds awesome. So it's a sine wave going up and down, changing the frequency. But it doesn't sound very musical. So how do I make that musical? I need to quantize it. So I'm going to take the output of this low-frequency oscillator and plug it into what's called a quantizer. This is an open-source module here. We'll see if this works. I need to give it a clock as well. And I need to take the output of that back into the synth. That sounds great. So there's notes. There's actually notes happening here. My God. It's kind of awesome, actually. Okay, but the range is too high. It's going super low and super high. So to control that, I can attenuate it. And to attenuate it, I need to lower the signal level of this thing. I'm going to plug it into an attenuator, and then I get some offset. Now it's starting to work. It's going in and out. Wow. Sounds like something's being overloaded. It's funny how it fades in and out. Oh, modulation off. Frequency open. So now I'm going to add something else. I need a clock signal, and I'm going to put in a sequencer now. So now this sequencer can, you can't see anything, can you? Oh, that's really frustrating. Okay. So I'm going to add something now. I'll take the pitch out of that into this oscillator here. And I'm running out of cables. And the output of that is going to go into the mixer, which it barely reaches. So this is a sequencer here. It's playing through a preset sequence. I can change the length of it. I can have it just be 2 notes. Or have it be longer so it repeats. And then I can add to that the other signal. Wow, that sounds awesome. What is going on? Oh, this is so unpredictably bizarre. Okay, thank you very much. All right. Good. Anybody have any questions or concerns? Oh. I didn't turn it off yet. But okay. So, thanks.
Golden Cat Award 2018. I don't know if you remember, this is I think the third or fourth year even. We started, I think 3 years ago, we talked about what could we do, how could we motivate our companies to develop good products. I don't think that the Golden Cat Award is the main motivator, but we thought it's a nice idea to show them some appreciation. And the Golden Cat Award has become something that really is part of this TX. We always launch at the TX the Golden Cat Award. That means today we have this golden little kitty here in the category apps, it's called. This is very random. And from now on, you can send in applications for 4 other categories. There's marketing, there's technology, product, and there's a Tamedia hero. Tamedia hero is something who's done something outstanding for the company. Yes, and printer drivers, exactly. Don't take the CTOs. And so from now on, you can actually send in the applications. We're going to pass you, we're going to spam you with emails over the next few weeks, of course. But today we want to start it off. And we thought, who could be the company this year who should get the Golden Cat Award 2018? And it was actually quite clear, right? Yeah, we sat together, and after a few seconds, it was clear to us there was one company this year that really exceeded. Not just did they build one of the coolest products that year, but also they changed their product team. They had a complete new setup. They redesigned their whole website. And ladies and gentlemen, what company would be better for a Golden Cat Award than a company that has developed a cat door configurator? Ladies and gentlemen, give it up for Renovero. Ladies and gentlemen, please come to the stage, everyone from Renovero. All right. And you got to know, we especially are quite happy to give it this year to Renovero, because for years we were always complaining, oh, you should do something. You should do. This year they actually did a lot, more than other companies. And so we're very happy to have you guys here. Say something nice.
Thank you very much. We really appreciate this. It's very unexpected. Nevertheless, we will continue our fight to free all cats by creating an even better cat flap configurator. So thank you very much. And we really appreciate this little kitty. It will get a special place in our office.
Congratulations. So, it's this time of day again. Thanks a lot to the great speakers of today's conference. I had a fantastic day. I hope you enjoyed it too. And I would like to share some impressions that I had this day. We started in this room some hours ago, the Snapchat pictures. We will take these snaps and try to convert them into a movie, giving some impressions of this year's TX. What I really loved about this year's TX were the war stories, the real experiences that got shared, the diversity of the topics that I listened to. I had to laugh so hard. I was really impressed by the content of the talks, the quality of the speeches was extremely high. So let's give a clap for all the speakers of this year's TX. Awesome job. One thing that really struck me during the presentations and that made me really proud were the cross-references. I don't know if you noticed, there were so many talks that were referring to each other. Like you heard from Tim before, how it was told by Janine just before, and people mentioning collaborations across whole Tamedia when they gave their talks. And that's something that I'm really proud of, that this is not this silo thinking anymore, but that people pick up on each other, that they know who the other person is, and that we collaborate in a bigger manner. So that's this one single thing that really struck me. Then I would like to share the badge of next year's TX. I don't know if you can see it. Yannick Sutter, yesterday night, just made a 3D animation on this little Arduino and made a prototype. It's a T and an X that are turning on this badge. Go and look at it again. So we're already trying to find out what we could improve for next year's conference. So, and now how do I get to the next slide? Here. Then I would also like to thank Norman again for the great sketches he did on Twitter under Tamedia TX hashtag. You'll find resumes of the talks that Norman has been attending, where he tries to every year wrap up the talk in one beautiful picture. I totally love this thing. We also learned about how we do geofences at Tamedia. That really impressed me. And I was able to make a last picture of Robin before he got fired for his talk at this year's TX. Yeah, it was great working with you, Robin. We also learned about the typical product development processes at Tamedia and how well they're working and how we're absolutely stellar in UX. Oh, that's the wrong picture. Sorry. We also learned a lot what will come up at next year's TX. I can't show all the pictures that we saw in this presentation. And also another thing that I learned is always be a doctor. Unless you can be a weatherman, then always be a weatherman. Thanks, Joel, for this beautiful quote. And so, to me, it remains to say thanks to everybody that helped to organize this conference, all the speakers, Shabi and his team that helped us setting up the stages and prepare the rooms, Adnan, Sibyl, Mara, Fabian, Simon, Yvonne, Helge, who helped as room hosts. Of course, Dennis and his crew from Verdino that helped with the catering and will do the catering upstairs on the 3rd floor, and the UX team for the lounge. And so, what's left? We tried to fulfill the back orders of all the t-shirts and hoodies. The demand was much higher than we anticipated, so we have huge lists of people still wanting more hoodies and t-shirts. We will order them again and then communicate with you about you picking them up at our offices. So, also, please use the feedback form that we're going to send you. We would love to hear from you what you liked, what we could improve at TX. And I hope you enjoy the rest of the day on the rooftop terrace, and we hope to see you again next year. But most of all, I would like to thank Core Engineering Eddie, Matthias, mainly for organizing the conference. You did an awesome job. I totally loved it. So please. So we've come a long way. What happened during today? I asked myself, where does Tamedia stand tonight? So during the course of the last 8 hours, we gained 0.7 sons to our reach. So by now, we have a reach of 32,000 sons. .71712852269. So that's something to celebrate. Thanks a lot for joining and have a great evening.